So our 4.3 lesson, we have to bring up some background information. So I'm just going to do a quick review on how to simplify radicals or how to break them down. All right, so the way that we've done this in our previous units is that we want to create a factor tree. So looking at this first example, if I want to simplify the square root of 112, right, I know that if there's no number there, my index is going to be 2. And that 2 tells me that I'm going to make groups of 2 with all of the prime numbers that are the same in my factor tree. So when I create my factor tree, right, I'm going to look at my radicand, which is the number under the square root symbol. And I notice that 112 is an even number. Right? So I can break down those first branches of the factor tree as 2 and 56. I'm going to go a little bit bigger this time because I know my factors of 56. So I'm going to go 8 and 7, right? Because 8 times 7 is 56. 7's a prime number, so I can stop on that side. And then I know 8 can be broken down into 2 times 4. And then 4 can be broken down into 2 times 2. So all of the numbers on the outside of my factor tree are prime numbers, which means that my factor tree is all the way at its end. Right? So the only numbers that I'm concerned about are the ones that are on the end of the factor tree. Right? So all of these 2's and this 7 that's hanging out on the other side. Right? Since my index number is 2, right, that means that I'm going to create groups containing 2 of the same prime number, right? So any prime number is where the factors are only 1 in the number itself. So like the only factors of 7 are 1 and 7, right? So that's why 7 is a prime number. So the first group I can make is with those 2's, right? Anytime I create a group, I'm going to put it on the outside of the radical symbol. Right. So I've got 1, 2, that's from this group. Right. I also have another pair of 2's that I can group together. So I'm going to group these together. And those are also going to go on the outside of my radical, like so. Right. And there's multiplication between those 2's. Right. I have this 7 left over that I can't pair with anything else. I would need another 7 in my factor tree in order to make a group there. All right, so this is what we call our leftovers. Right, and my leftovers always go back under the radical symbol. So my last step, I've got 2 times 2 on the outside. I want to make sure that I simplify that. So 2 times 2 is 4. And we're just going to rewrite the radical symbol. So my final answer is 4 root 7. We can also do this with our perfect squares. So I know that 49 is a perfect square, right? Or 7 squared equals 49. So if I rewrite that radical as the square root of 7 squared, I know that the square root and the exponent of 2 undo or cancel out each other's operations. So I know that the final answer is 7 when I simplify the square root of 49. Right. If you want to do your factor tree, right, we can break down our factor tree with 7 times 7. Right. We can create our one group or a pair of 7's, and there's no leftovers. So my final answer would be 7, which is the same as what we got using the other method. And then our last example, right? This one's got a coefficient on the outside, so we're going to take that into account at the end of the problem if we've got groups that we can put on the outside of our square root symbol. So I'm still going to use my factor tree here. I know 72 is an even number, So I'm going to break that down to 2 times 36. Now in my factor tree, I could keep breaking this down by 2, but I know my perfect squares, and I remembered that 36 is a perfect square, or in other words, 6 times 6 gives me 36. And so since I know that 36 is a perfect square, I can stop my factor tree here with this pair of sixes, and put that on the outside of my radical symbol. All right. We always want to make sure to bring down that 5 that was hanging out at the front. Right. And I know that this 2 in my factor tree is what's going to be left over. So I have 5 times 6 times the square root of 2. If we want to simplify that, I'm going to multiply my numbers on the outside. So 5 times 6 is equal to 30 times the square root of 2. So if you're ever a little unsure or you don't want to use that way of knowing your perfect squares, right, you're more than welcome to extend your factor tree all the way. Right, so say we still start out with 2 times 36, and we do 2 times 18 gives me 36, and then we do 2 times 9, and then 3 times 3. Right, these are all prime numbers on the outside. Right, so we're only concerned with these 3 2s and the pair of 3s at the bottom. Right, my index number is still 2 here, so that means I'm going to make groups of 2. Right, so I'm going to make a pair of 2s here, making sure to write it on the outside of my radical. I've also got another pair of 3s here that I'm also going to group and put on the outside. Right, there's always multiplication in between, and then we can't forget, again, that 5 that was hanging out in the front. So I'm going to multiply that here. Right, I still have this leftover 2 that I can't pair with anything else, so that's going to go back under the radical. And always my very last step is to make sure that I simplify as much as I can. So if I do 5 times 2, that gives me 10 times 3 times the square root of 2, and 10 times 3 is 30. Right? So we still get the same answer if we choose to break down our factor tree anymore, or if you choose to stop at that perfect square of 36, you'll still end up at the same answer.